Hello world, I am Christopher Magashek, and today I will be showing you how I made Namco's 1980 arcade title Pac-Man, written entirely in Java. My main goal with this project was to try and make as faithful of a recreation of the original arcade title as I could, even down to adding the character roster at the beginning and the little demo as well. I started this project back in January 2023, and it took me about, well, actually, I should say I spent 4 weeks on it, and then after that, I kind of got caught up with schoolwork, and I kind of haven't revisited it since then. But I feel like I did like most of it, like down to just like correcting a few little details. Um, so yeah, let me show you. Yeah, I even made sure to add the little sounds. Um, yeah, I tried my best to recreate as best as I could, like, even making sure the ghosts leave the ghost house at the correct time, um, making sure the cherry pops up at the correct time, whoop, adding the Pac-Man death, with the complete with the animation. Um, yeah, this was a pretty fun project to make. And I even like made sure to So if you see, we enable the rack test, which was actually a feature they had in the original arcade title. It was kind of this hack you could use to skip levels. Um, so here we see the cut. I even added the cutscenes as well. Um, so yeah, um, it's not perfect, of course. Like right here, it played like 2.5 measures of that when it was supposed to do just two. I think I was about to fix that, but then like that was around the time I got caught up with schoolwork. But anyways, let me show how I wrote this actually. So first things first, I wrote this in Processing Java. That's a library created by the Processing Foundation that makes it is written to make it easier to teach people to program, but it's also good because it provides a lot of graphical libraries that just remove a lot of the overhead of like drawing things onto the screen. It also came with a sound library, which is how I got all the sound working. Um, I also could not have done this without this lovely document right here, the Pac-Man dossier by Jamie Pittman, which is it was meant to be a strategy guide for this game, but it provides such excessive details on its mechanics that it basically doubles as an implementation guide. I used a lot of the stuff here listed to help me program the game, um, and understand like the mechanics behind it. But yeah, first things first, I had to make the maze, which is a 32 by 32 grid embedded on a torus. They're actually, so some of the grid squares on the left and right are hidden, because they wanted there to be a little bit of time between when you leave through the tunnel on the right and when you enter on the left. Um, so yeah, but it's a 32 by 32 topological torus, meaning if you go too far right, you end up on the left, and vice versa. And if you somehow broke through the walls, then if you went too far up, then you'd end up on the bottom. But that's not something you could really figure out unless you played level 256, which is where everything ends up getting broken. Um, but yeah, so I made sure to implement it that way. So first things first, I had to implement the I vector, which is similar to processing's P vector, a geometric floating point vector, but this one is using integers, to sort of respect this topology right here. Um, so made sure to implement all the necessary functions such as addition, subtraction, multiplication, division, uh, modulo, so that you can like wrap around, as well as a bunch of bitwise operators and even the glitch dad. For those who don't know, there's this little glitch that happens sometimes in the game where the game is supposed to calculate something that's like a few spaces above something else, but instead calculates it a few spaces diagonally, um, le- up left diagonal. It had to do with like the way that the coordinates were stored. Basically, the negative y coordinate would end up overflowing onto the x coordinate, and this was like a very subtle detail in like the that mostly just affected the ghost AIs, and so the developers didn't really pick up on it until after the fact. Um, but it's very easy to patch as well. In fact, I think they did that in the DS version of this. Um, and in here, it's easy to patch. You could just change all instances of glitched add to just add, or you could just remove this line right here. And also, I have to mention, I'm not sure why I wrote it like this. I mean, having four different commands on one line is kind of pushing it in terms of, I guess I just didn't think much of it at the time. I mean, I was able to read it, but it's really pushing it in terms of readability. But anyways, and I included these bitwise operators as well because um, the thing with the original arcade title was multiplication was pretty expensive back then, so they did their best to try and reduce multiplication as much as possible, and if possible, replace them with left shifts and divisions with right shifts. I don't think there were any actual divisions in the original game because that's a very expensive operation. Um, and to be fair, we could just, instead of using modulo, since it's a 32 by 32, we could just use the bitwise um, and them with 31. But the thing was, I wanted my code to be reusable. Like, let's say, in case I or one of my friends wanted to modify this program and make it so that the maze was bigger. Um, like, let's say, it's 81 by 81 or something, something that's not necessarily a power of two. Or, in general, like what if you wanted to change all the sprites to be like Simpsons characters or something? So yeah, I made sure to the best of my abilities to make it so that it was reusable and so that it could be easily modified. And so that's why we have these mod functions. Um, but yeah, so after that comes the grid. I don't know why I called it grid. It'd probably been more accurate to call it a tile, but the grid represents each tile on the board, um, and all its properties, like such as whether or not there's a barrier, like which whether or not there's a barrier above, below, left, and right of it. Because a little known fact is that when you reach level 256, you find that there's it's possible to have blocks that are only barriers on certain sides, like one-sided barriers, for instance. Um, but as well, so it encodes all the important information about each tile, and so in addition to that, we have the maze, which holds the 2D array of grid squares, and as well as a bunch of other important information like how things are drawn, um, the list of actors, because the ghosts in Pac-Man, they're considered actors because I can't call them characters. That name is taken. Um, but yes, yeah, so we have the list of actors in the game. The game itself, in case you want to have like multiple instances of the game running at the same time, like let's say if you wanted to make like a neural network trained to play Pac-Man, um, and a bunch of other important stuff such as what level you're on, uh, how many dots are left, how many ghosts you've eaten in a row. A big fancy mechanic involving dot counters, which like the mechanics of this game were very intricate. There is this thing involving dot counters that would determine when the ghosts would actually leave the ghost house. And interestingly enough, there was actually an exploit in this where after if you die, you can like eat the pack dots in a certain order that makes it so that none of the ghosts except Blinky leave the ghost house. And wanting to be as faithful as possible to the original game, I made sure to implement it so that that glitch will happen if you do it the right way. Um, so yeah, what else do we have? Um, I made sure to make it so that you could actually like load mazes from a file because again, reusability. Um, and so here we have the original maze file with stars representing walls, periods representing pack dots. The P's actually represent passageways because if you don't know, there are like these four tiles in the game where the ghosts are actually forbidden from moving up through them, not moving down, just up, and only the ghosts. Um, and also the gates, which are kind of the other way around, where only the ghosts are allowed to move through the gates. Pac-Man is not. So yeah. But then also, I because the level 256 is completely broken, its boundaries are a lot different. So I spent a lot of time painstakingly trying to figure out the boundaries of every tile in level 256, which I was able to do using an emulator. I was able to use the rack test to make it to level 256, and then I save stated that so I could explore it. But unfortunately, they don't have like any sort of like invincibility hack. Unless they have a rack test, but they don't have any sort of invincibility hack. So you basically just have to repeatedly load the save state if you die too much. Um, but anyways, what else? Yeah, let's close that. Um, let's talk about the actors right now. Actually, so um, again, the actor represents Pac-Man and the ghosts. We of course have name, the maze it's part of, the game it's part of, the animation state. Now, animation is almost entirely handled by the artist because single responsibility principle. The artist is in charge of drawing things. Um, but the at the very least, the actors still need to you still need to know what animation state they're in. Let's see the tile because when the game calculates hitboxes, for all intents and purposes, they just narrow down your coordinates to one of these 32 by 32 tile spaces, and if you are in the same space as a ghost, that ghost is eating you, or you could be eating the ghost. Um, and so that's the whole reason for the integer thing. Meanwhile, this, which I guess I called it the atomic position. I don't know why I called it that. I guess I just didn't know that atomic was actually a word that existed in programming at the. Um, so that's probably poor naming choice. But anyways, I guess that's just what it's called now, the atomic position, which stores like a floating point position, because when you move, you don't immediately move from one square to the next. You sort of transition between them, and so that's important animation wise, and also in terms of when knowing when you've moved to the next tile. Um, let's see what else we got. The current direction, next direction, previous direction. This thing called cornering, which is where I don't want to get into too much detail, but there's this thing involving when you the moment you enter an intersection point, you were allowed to immediately start moving. You're allowed to immediately start turning, whereas the ghosts are only allowed to start turning the moment they reach the center of the intersection. Um, yeah, there's a lot of fancy mechanics behind this. What is it? Let's see. So we go. Oh, and they also have a brain. I'll talk about that later. Um, let's see. Um, we have the wraparound function, which tells it to wrap around like on the torus. The update position, which says to update the tile position based on the atomic position. Um, movement, which basically the algorithm is first you calculate the tile that you are currently in and calculate. You say, okay, I want you to move towards the center of that tile, um, and then after that, you sort of look in the direction you're currently going in, and you perform some tests, such as making sure that going there wouldn't cause a collision, as well as some other stuff involving the mechanics of the game. And then, if you're allowed to, then you change that target tile to be to the tile right in front of you. And then after that, finally, you try to move towards the center of that tile, and then you wrap around and update the tile position. Um, let's see. Yeah, lots of fancy mechanics in this game. Um, collision detection. Um, this thing right here, which is determining whether or not you're allowed to pass, such as through a passageway or through a gate. Um, progressing one frame, updating, and then naturally we have that was just an abstract class. We have the derived classes Pac, which represents Pac-Man or Miss Pac-Man or whatever Pac creature you want to make. But in this version of the game, it's just Pac-Man. The ghosts, of course, which I had write quite a bit of code because The ghost house was actually very difficult. See, the thing is, it's a 32 by 32 grid, so there's a two block center. But despite that, and so that means that like when you're moving like say down through a corridor, you have to be horizontally centered, and likewise when you're moving left and right, you have to be vertically centered. But I guess when you're inside the ghost house, though you're governed by a different set of rules because as you can see right here, despite it being a two block center, um, Pinky it moves is it stays halfway between two tiles. The same happens for Inky and Clyde as they move up and down in the ghost house before finally leaving, and then they finally align themselves with a tile. So that was a huge headache. Um, Still don't know how they originally did in the title, but that was that required quite a bit of extra work to get that working. Um, let's see, Elroy mode. Yeah, there's this thing towards the end of each level where Blinky will turn into what the fans call Cruise Elroy mode, where Blinky being the red ghost, where he basically, first of all, he speeds up, and second of all, he will, if he's told to stop chasing Pac-Man, he will ignore that and will continue chasing Pac-Man. So that's just something else to keep the game interesting towards the end. But of course, it also has an exception. Like if you die, then he won't. Even if you die, even though you're towards the end of the level, then he will stop being in Elroy mode until after the ghosts leave the house. Like I said, there's a lot of mechanics in this game. I couldn't explain all of them. Excuse me, that would take too much time. Um, oh, and then interestingly enough, the fruit are also actors. I think that's how it was in the original title as well, because the cherry is actually is there any images of the cherry? Well, anyways, the cherry is like drawn right in the middle, right here, and pretty much the only way to place something between two blocks, um, I think in the original title was just if it was an actor, then you could do that, and it could like have like a atom position between two tiles, and it would be displayed like that. I think that's how it was, but I could be wrong. I suspect that's how it was because Ms. Pac-Man was just a mod of the original Pac-Man, and in that game, the fruit would actually bounce across the screen, moving like an actor. So I suspect that they were able to do that because it was already written to be a movable entity. Um, but anyways, um, let's see what else. Oh, I was going to talk about the brains. So some people probably might already know this, but the ghosts have like a very interesting set of behaviors in this game. So let's see. Um, let's close that. What is it? They have. Hold on. Come on. Control F. Scatter. Yeah, here we go. So they have basically three main modes. There's chase mode, which is so they start out in scatter mode at the beginning of the level, which is where they just move towards they just move towards a specific fixed tile, and that's their target tile. So Blinky will go there, Pinky there, Clyde there, Inky there, and then they periodically they'll switch between scatter and chase mode. And chase mode, all four of them have different versions of chase mode because if they didn't, if they all had the same algorithm for chasing Pac-Man, then eventually they'd all just converge towards the same tile, and it'd basically be the same as only having one ghost chase you around. Um, so the A.I.s are Blinky. He will target towards where he will try to pathfind towards where Pac-Man currently is. I suppose I should clarify. The way they pathfind is when they reach an intersection or any point where they can change direction, they will look at the surrounding four tiles, and to determine which one to go in, they will look at all four of them and then see which one is closer to their target tile. Um, and it might seem like, well, Pythagorean distance more specifically, but that they actually, because again multiplication was very expensive back then, so to avoid this they'd actually They kind of use this little cheeky thing to avoid multiplication altogether, so they wouldn't have to calculate the Pythagorean distance. Basically, this fun piece of very simple but very elegant vector algebra makes it so that comparing two distances would basically just boil down to two dot products, and because the dot products are with unit x vectors or unit y vectors, it basically just boils down to comparing the x value, y value, negative x value, negative y value, and seeing which one is bigger, or is it bigger or smaller? Well, it depends if you're targeting towards or away from them. But anyways, and so that's how they do it. But also there's this other thing where they were forbidden, no matter what, they were forbidden, first of all, from going through walls, but second of all, from turning around. Because if they were allowed to turn around, then let's say if Pac-Man's right here and Blinky's right here, he moves down, trying to get towards Pac-Man, and then he moves down again. But now he tries to move up to get towards Pac-Man, and then up again, and now he tries moving down again, and then up, and then down, and then up, and then down, and never gets any closer to him. So in order, I'm guessing, I have to imagine they actually encountered this problem while programming this, and they realized, okay, in order to stop this from happening, we have to forbid them from turning around. Except there is a very specific case where they are allowed to turn around. It's when they switch between scatter or chase, or vice versa. Then they turn around, and I think that's sort of a signal to the players that they've done that. Um, anyway, so Blinky moves towards the target tile. Pinky moves towards. Sorry. Blinky moves towards Pac-Man. Pinky moves towards where Pac-Man will be 4 tiles from now. 4 tiles in front of Pac-Man. And once again, it uses the glitch dad to calculate this. So if Pac-Man's going up, Pinky will actually look at the position 4 tiles up and 4 tiles to the left. Um, Inky Inky's actually got a very strange behavior. What he does is he tries to flank Pac-Man using Blinky's position. So wherever Blinky is, he tries to be on the opposite side of Pac-Man with respect. So it'll take Pac-Man's position minus Blinky's position plus Pac-Man's position, and then after that add 2 tiles in front of where Pac-Man is. And the whole point of this was to try and flank him so that like as Blinky closes in on Pac-Man, Inky closes in on the other side, trying to prevent him from escaping. And then Clyde, meanwhile, Clyde sort of just does his own thing. He basically, and this was one of the few cases in here where it actually uses multiplication. Basically, it calculates how close Clyde is to Pac-Man, and if he's greater than 8 spaces away, he will move target towards Pac-Man. But if he's closer than 8 spaces away, he will instead target towards the bottom left. Clyde's not the smartest. But yeah, this was one of the few cases where they used multiplication. In fact, I'm pretty sure they didn't even have a dedicated multiplication circuit anywhere in there because someone actually was able to decompile Pac-Man's hardware into assembly language. And if you look in here, there's absolutely no multiplication whatsoever. So I think they literally just like manually did bit register shifting using the move and add commands. What about times symbol? Nope. What about times? Nope. Yeah, no. No direct multiplication anywhere. Um, so that's pretty interesting. But anyways, what else do they do? Oh yeah, right here we see their scatter modes where they just move towards a tile, except Blinky, who if he's in Elroy mode, he'll continue to move towards Pac-Man. Um, what else do we have? The random thing, that's just the when you eat the Energizer pellet, then what they do is they will just move around randomly basically. And this was one of the biggest discrepancies between this and the original Pac-Man because the thing is Pac-Man's RNG was deterministic. Like every time you restarted the game, insert coin, press start, then the RNG would get reset, and so that made the game deterministic. But I could not really do that because like the way it calculated it involving literally knowing like the values in specific address spaces in the game, so that just wasn't going to happen. So I instead just used processing. I instead just used Java's built-in random function. So that's good enough. Let's see, base enter. Oh yeah, that's when. Actually, I think it's this one. Yeah, that's when you eat them and they turn into floating eyeballs. They move towards the base to try and turn themselves back into ghosts. And then there's other AIs as well I had to make to animate them leaving the ghost house because again the ghost house was a huge pain. Oh yeah, pack demo. That's right. Because oddly enough, unlike most arcade titles where they just had like they would show the demo as just like a preset set of like movements. Instead, here they actually they just had the game running with all the ghosts still having their AI and Pac-Man using a specific AI they made. Um, it's not very intelligent at all. Basically, the I think the entirety of it is if Blinky is currently edible, then you move towards Pinky. Otherwise, you move away from Pinky. And I think there isn't really any strong logic to it because I think all they wanted was just they just kind of finicked around with it, with different possible AIs until they found one where the demo screen looked interesting enough. Um, and of course, the demo does play the same each time for them because again, the RNG is deterministic. Um, but I couldn't do that, of course. So the demo screen will just play a different thing each time, or at least it'll be different each time. The moment that he collects his first Energizer pellet. Before that, it's still deterministic. But yeah, what else do we have here? Um, let's see. Single responsibility principle. I made sure to have an artist in charge of drawing things, a DJ in charge of managing the sounds, choreographer is in charge of choreographing all the events in the game, such as the when the game is paused, showing the ready thing, ready player one, then it tells you when to stop doing that and start the game. It also choreographs all the cutscenes and Pac-Man's death animation and the character roster at the beginning, all that stuff. Let's see, what else do we have? The game, of course. Um, the updater. The updater is in charge of performing the updates every single frame, um, such as updating. It updates the game every frame, and then in there it also updates the maze, and then in update maze, on top of some other important stuff, it also looks at each actor and then performs a function called more updates. Um, which yeah, here what does it do? It basically well for Pac-Man it manages eating things or Pac-Man dying, and then for the ghosts it manage a lot of stuff. Wow, a lot of stuff. Oh, that's right, because their AIs constantly change, whereas Pac-Man, when he has an AI, it's always the same. Um, I'd love to see someone actually like take this game and like implement like a neural network for Pac-Man and like give him like an intelligent AI. That'd be kind of cool. Fun fact is, if you turn on the rack test during the demo screen, he actually will go to the next level, and they even play the cutscenes. So that's real funny. Um, eating pack dot, eating Energizer pellet. Fright mode, which is where you eat the Energizer. Frighten ghost, disable fright, because once they go into the ghost house, then they're done with that. Managing the dot counters. Yeah, lots of important stuff. Force kick ghost, because in general they manage when the ghosts leave um based on how many dots Pac-Man has eaten. But if he goes long enough without eating any dots, then they'll just force kick him so that they'll just force kick the ghost so that you can't just exploit the system. The game's got to progress. Although I guess that's not much of an exploit because you can't win that way. Um, and then we have the game values, which it sort of depicts things such as just the arbitrary game values, such as how long between the scatter and chase modes in each level, or how fast each actor can go. in each level, etc. And these can easily be edited by the programmer at the programmer's discretion if they want to change up the gameplay a bit. Um, Miscellaneous. I think this is just where I put a bunch of enums here, because the thing with processing is it's actually written as if everything you write is just a member of the papplet class. So the tabs, unlike usual Java programming where each tab is its own dedicated class interface or enumerated type, here the tabs are just for organization. You could put multiple classes in here, for better or for worse. I feel like here it's pretty appropriate. I mean, this one literally is just one interface with one function that doesn't really need its own tab. Um, but anyways, so anything else here? Oh yes, of course. So naturally, I also added a pause screen with buttons on it because I wanted to add a few things to it. Um, first of all, so you could change around because when you first start up the game, you actually have options about what you can have on, like how many lives you start with. One, two, three, or five were the default options, but I also added four and infinity. Although I guess the symbol didn't render for some reason. You get to choose how many points it takes for a one up. You get to choose the credit rate, which um, the reason I didn't just only have free play mode because if you set it to free play mode, they won't show the character roster at the beginning or the demo at all, and so it's like, well, it's taking away quite a bit of the game, I guess. Um, so yeah, I added all four of the modes, even though it really just boils down to how many times you have to press shift. Difficulty, they had it normal and hard mode, and then for some reason they also had alternate names, which is really funny. It just does this. Um, yeah, I think that might have just been to test out the text display, which, whatever. Um, but yeah, I also added a few other things, such as the ability to add or subtract lives in the middle of the game, as well as invincibility, which is something that did not exist on the game. Um, I had to implement that hack almost immediately because just so that I could test things out. So that because if I keep dying, then that just makes it very difficult to hold on. Did I? Oh, I forgot to enable it. So yeah, here we go. So I just pass right through them. Um, and so that was important so that I could thoroughly test out the mechanics of the maze and make sure it all worked correctly. Um, and then what else? And the rack test, of course, was also important for implementing the cutscenes, because there's no way I could make it, past level 5 every time. Um, let's see. Oh, I also did something that I've never seen in any version of this game, which is I made it so you can switch players. So first of all, I have to be invincible for this, otherwise poor Pac-Man here is going to die immediately. But I'm going to switch players to Blinky, the red ghost. Um, and now Pac-Man is just running with the AI that he has in the demo screen. And if I want, I can just go back inside the ghost house. That's something that, like, I don't even know if the ghosts are allowed to do that unless they've been eaten. Um, but yeah, I decided to do that anyway because I thought it'd be really cool. Uh, Although I do sometimes get stuck because, again, the ghost house is very broken. I still don't get how they wrote it in the original game. It makes sense they wouldn't document it, though, because, like, it's not really important that much to, people who just want to, like, beat the game to 100%. But anyways, naturally, Pac-Man doesn't really have any incentive to, get all the Pac dots because his AI wasn't written to be smart. It was just written to make an interesting demo screen. But let's see if I can get eaten. So, just eat me. There we go. And so now I'm just a set of floating eyes. And I can move wherever I want. I don't have to go back to the ghost house if I don't want to. And I'll just play that music, that sound forever. Um, oh, yeah, I guess also, for some reason, I didn't make it so that I made it so that the player wouldn't get blocked from going up through these, but the which I guess I don't know why I did it that way. I think it really should be that like the ghosts aren't allowed to move up through those passages. It shouldn't depend on who the player is. Like I said, I did this like well over a year ago, so I don't really know. But anyways, so is there anything else? No, I think that's about it. So yeah, this was a lot of fun to make, and I hope you enjoyed seeing how I made this, or at least a glimpse into how I made it. Because again, there's no way I could go over every single detail. This was a pretty intricate game. It was very impressive at the time. Um, I mean, it was like literally implemented entirely in hardware, unlike modern games, which are you basically just have a computer that runs code, which is practical now, but that wasn't at all practical back then. Um, so, anyways, yeah, I hope you enjoyed this, and yeah, see ya.